second order differential equations. They are equations of the form a the square y dx squared plus b dy dx plus cy is equals to f of x, where a, b, c are constant in the set of real numbers. F of x is a function in x. Another name for this second order differential equation is called the complete equation. This equation can still be written without the function on the right hand side of the equal sign, that's without f of x, or when f of x is 0, that is, it can still be written as a the square y all over the x squared plus b dy dx plus cy equals to 0. When the second order is written like this and the right hand side of the equal sign is 0, then the second order is called the homogeneous equation. Remember that we also call this the second order differential equation because the highest derivative is 2. Let's say I take y to be equals to a times e to the mx, then dy dx will be equals to ma e to the mx. You know, a is a constant and the differential of e to the f of x with respect to x is the same like e to the f prime of x all over f of x. That's why I had ma e to the mx, because the differential of mx is equals to m. Since the differential of x is 1, so the differential of mx is m, so that's why I wrote m here. Also, the square y the x squared is equals to m squared a e to the mx. That is, I differentiated e to the mx again and I have m. Multiply by this, I have m squared. Now, if I substitute this information in this equation, I will have a m squared a e to the mx plus b m a e to the mx plus c a e to the mx equals to 0. This term is common, so if I divide all the terms in this equation by a e to the mx, that's all over a e to the mx all over a e to the mx, you see this will cancel, this cancel out, this cancel out, and then I'll be left with a m squared plus b m plus c is equals to 0. This equation is called the auxiliary or characteristic equation of this differential equation. You have to know that the solutions to the second order homogeneous equation a the square y the x squared plus b dy dx plus cy equals to 0 depends on the solution of the auxiliary equation m squared plus bm plus c equals to 0. Now, if the roots of this auxiliary equation are real and distinct, let's say the roots are alpha and beta, then the solution of this homogeneous equation is given by the formula y equals to a e to the alpha x plus b e to the beta x. Now, let's take an example. Find the general solution of the differential equation 2 the square y all over the x squared minus dy dx equals 0. To find the general solution of this differential equation, we need to look for the auxiliary equation. The fastest way to look for the auxiliary equation is to replace dy dx in this equation to be a variable, say m. You know, if I compare this differential equation to the general differential equation of the form a the square y the x squared plus b dy dx plus cy equals to 0, you will see that the term cy in this differential equation is equals to 0. Now, if the term was there, to get the auxiliary equation is to take dy dx equals to m and then y equals to 1 in this term. If I take dy dx to be m in this equation, I will have the auxiliary equation as 2m squared minus m equals to 0. To solve this auxiliary equation, I can factorize out m, and this will give me 2m into m minus 1 is equals to 0. You also have to know that the auxiliary equation is always a quadratic equation. So solving this is like solving a quadratic equation. That means 2m is equals to 0 or m minus 1 is equals to 0. If I divide both sides by 2 here, that is 2 over 2. 2 we cancel 2 and I'll be left with m equals to 0 or m is equals to 1, since minus 1 crosses the equal sign positive. Now it means in this case the differential equation is having two real and distinct roots which are 0 and 1. So it means alpha is equals to 0 or beta is equals to 0. You see, substituting in this general formula, I'll have y is equals to a, which is a constant, e to the 0x plus b to the e times 1x. That is, y will be equals to e to the 0 times x is 1. This will become a plus b to the ex. So it means the general solution of this differential equation is this. Now, if the roots of the auxiliary equation am squared plus bm plus c equals to 0 are repeated real roots, this is a quadratic equation which is supposed to have two roots. Now, if the roots are two and the same, let's say if the first root is alpha and the second root is still alpha, so we say the roots are repeated, and we will conclude that the root of this equation is alpha. When the roots of this equation are repeated, then the general solution of the differential equation is given by the formula y equals to a plus bx e to the alpha x, where a and b are real constant. Now let's apply this formula in solving an example. Find the general solution of the differential equation, this square y dx squared plus 6 dy dx plus 9y equals to 0. The first step to solve this differential equation is to look for the auxiliary equation. Like I said before, the fastest way to look for the auxiliary equation is to imagine that if m is equals to dy dx and y equals to 1, then the auxiliary equation will be m squared plus 6 dy dx, which is m, plus 9 equals to 0. This way of getting the auxiliary equation works for all the second order homogeneous differential equations. So now I need to solve for m in this quadratic equation. So I need to look for factors of 9. When I multiply, we give 9, and when I add, we give 6. That is the coefficient of the middle term. Now the factors of 9 are 3 minus 3, 1 minus 1, 9 minus 9. Now if I take 3, that is 3 times 3 will be 9, and if I take 3 plus 3, I'll have 6. So it means that the required factor here is 3. That is m into m plus 3 equals to 0. M plus 3 is equals to 0. That means m is equals to minus 3. Since the factors are the same, here we'll take alpha to be equals to minus 3. Substituting alpha equals to minus 3 in this formula, I'll have y is equals to a plus bx into e to the minus 3x. That means y is equals to a plus bx to the e minus 3x is the general solution of this differential equation. If the roots of the auxiliary equation a m squared plus bx plus cy equals to 0 are complex conjugate roots. Let's say if I solve this quadratic equation and I have the roots as m equals to alpha plus beta I, or m equals to alpha minus beta I, then the general solution of the second order homogeneous differential equation is given by the formula y equals to e to the alpha x into a cos beta x plus b sine beta x, or y is equals to a e to the alpha x cos beta x plus epsilon, where a, b, and epsilons are constant that can be calculated. Now let's apply this in solving an example. That is, find the general solution of the differential equation d square y all over the x squared plus 4y equals to 0. DE here is an abbreviation of the word differential equation. Now to find the general solution of this differential equation, I need to start by looking for the auxiliary equation. If we set m equals to dy dx and y equals to 1 in this differential equation, then the auxiliary equation will be m squared plus 4 is equals to 0, since the term dy the x is not there, and here we have the second derivative, so I have m squared here plus 4. To solve this equation, I make m squared the subject of the formula. I have negative 4 the other way, that is m is equals to the square root of negative 4, which is equals to plus or minus 2i. You know, the square root of minus 4 means the square root of minus 1 times the square root of 4. From such, we know that the square root of a times b is the same like the square root of a times the square root of b. It means here the square root of minus 1 times 4 is the same like the square root of minus 1 times the square root of 4. I plus or minus 2. So it means I times plus or minus 2 is plus or minus 2i. That is, there's a bracket here. So in this case, alpha is 0. So it means the complex roots are m is equals to 0 plus 2i, or m is equals to 0 minus 2i. And then the general solution will be y equals to e to the alpha, which is 0x, into a cos 2x, since beta is 2, plus b sine 2x, here is b. Now 0 times x is 0, e to the 0 is 1, so it means the general formula is y equals to a cos 2x plus b sine 2x. So this is the general solution of this differential equation.